Hello, my name is Gus Ubaldi, and I will be your instructor this semester for the online course Construction Print Reading CNST 1731. What can I say about print reading? Let's take a look at this aerial shot of the little town where I grew up. I lived up here in the northwest corner of Long Island, and my dad had a butcher shop down in Greenwich Village. And to get from my house to my dad's shop, you would need a map. And print reading is like map reading. You have legends, you have symbols, you have distances, and while a map helps you to navigate a city, prints help you navigate construction. Now, the text primarily deals with new construction, but in your careers, you may often be confronted with existing installations and old plans. The book also deals with buildings, but then not all construction is a building. So in my career, I have worked on highways and bridges, embankments, and paving projects. So during the course of this semester, I will try to expose you to types of construction other than buildings. Print reading isn't just limited to simply reading prints, because we can't take the drawings alone. We have to rely upon specifications, because words mean things. The legal requirements, sometimes known as general provisions or boilerplate. Contract administration. How does the project going to be progress? So that leads us to rule number 1. Anytime someone gives you a single print out of a set, spit in his eye, because they are not doing you any favors. Print reading also includes other disciplines, such as surveying, scheduling, project management, bidding process, and code requirements. Other things included in print reading: calculations. Math is an essential part of print reading. So in addition to calculations, we may have to do quantity takeoffs or cost estimating, which leads us to rule number 2 of print reading and rule number 15. Rule number 2 is that math is our friend, and rule number 15 is that multiplying a number by 1 will not change the number. And this is especially important when we're dealing with conversions. Now, I am going to assume that everybody is familiar with certain concepts like algebra and trigonometry. If at any time you don't understand, please contact me with your questions. This list of sample conversion factors is included on Blackboard. These are some of the more common ones that you might come across in print reading. Print reading also includes the designers. Somebody has to put those plans together. Someday you might become one of those, or you might be one of those now. Of course, it includes the contractors, the entity that is going to build the project. Now, you might be tradesmen, you might be foremen or superintendents, or, God forbid, you might be the owner. Or you might be a construction manager who works between the contractors and the designers to see that the project is completed properly. Print reading, especially this text, talks about new construction, but you may be confronted with reconstruction or remodeling, which means you will sometimes be working with new plans, but sometimes you might be working with old plans, sometimes with very old plans. It also includes buildings, and again, as I said, this text focuses on buildings. They might be residential, they might be commercial. Then there are those projects that are non-buildings, which pretty much covers everything else. Print reading is a prerequisite at Cuyahoga Community College for CNST 1410 Architectural CAD, for 2131 Construction Methods and Materials, which I have been teaching these last few years, so if you move on, you may wind up with me again. And for CNST 2201 Introduction to Building Information Modeling. Some of our objectives in this class, I want you to be able to describe what's required on the drawings for construction and civil engineering projects. Describe the meaning, the need and specifications in a project manual and be able to find them. Determine the unit quantity of required materials for a construction project based on those drawings. Differentiate between the different types of working drawings for construction. Identify and explain specific components of a working drawing for construction. Visualize and describe the intended structure which is depicted on that drawing. Outline the steps and methods in order to get a building or a structure completed. Why do we need drawing revisions and how do you identify them? Summarize the process to prepare drawings in a complete contract document package. How does a project manual relate to a set of working drawings? And become familiar with the format of specifications in project manuals. And as we get on, you will see that this will vary in many, many different cases. The course outcome is to apply that knowledge of the presentation methods, the interpretation, the sequence of preparation, the bid submittal process, the revision control, and code requirements for construction drawings. Now, the way I have structured this course, there are certain techniques, just as there are techniques for carpentry, pipe fitting, or electrical work. There are techniques for print reading, and we will address those. And we will look at them in the same way that we might build a house, working on the site first, then the foundation, then the walls and the roof and the interior. The end result, I will not be able to cover every imaginable print that you might encounter in your career. But we are going to talk about building plans and non-building plans. What I will give you will be a set of tools that will allow you to read any print or any set of plans. As I was told many, many years ago when I was first hired by the railroad, it's not what you have been taught, but how you have been taught to think. And hopefully when this class is over, I will have given you some insight as to how to think. Some housekeeping. If you have to contact me, there are a number of ways to do so. You can use my Tri-C email address, which is listed here. You can phone me. I have a campus number and I have a cell number. And I do stop by the office on the Western campus periodically. Now, some caveats. The best way to get a hold of me is by using my Tri-C email. My cell phone will work. It'd be more beneficial to text me because I may not always be able to answer the phone, but I can respond to a text. The office on the Western Campus is a possibility. I am teaching a course there periodically, but I only check the office when I am on campus, and that's only 2 days a week. Do not even try the campus number. I won't explain the rationale, but it is not one that I maintain. I don't know when there are voicemail messages, and so I can't be prompt in doing so. If I have to contact you, I will use your Tri-C email address. So be sure you have a way to check that periodically. Some more housekeeping. If you need to withdraw for any reason, if you withdraw by January 20th, there will be no record. If you withdraw by this date, you will receive a W on your record. After that last date, then you are at risk for whatever grade your performance merits. Some more housekeeping. Since this is an online course, we will be using Blackboard. Each week there will be a video with a presentation like the one you are watching now. Assignments and quizzes will be on Blackboard, and you will be able to answer the questions and submit it on Blackboard. Those assignments and quizzes will be based on the presentation you watch and whatever reading assignment I provide. When you answer those questions, it will not only tell you whether you are right or wrong, but then an explanation as to why that is the case. They will be available at the beginning of each week and will be due by the following Monday at 11:59 p.m. You will not be able to take the assignment or the quizzes after that due date. And in the first week, presented as an assignment is the student contract. All you need to do to complete that is the answer to the question is your name. Last name, first name. If it were me, it would be Ubaldi, Augustine F., period, just as it appears in the college record. Submit it, and you will not only have completed the student contract, but gotten your first 10 points in assignments. More housekeeping. Handouts will also be available for each week's work. And as we go through the presentation, you will see the little Blackboard symbol that will indicate that it is available. That may not always be the case, but it helps. Please read the syllabus. That's part of the student contract. Make sure you have read all the notes. Check with DegreeWorks to see how close you are to getting your degree. And a standing class rule is the syllabus is dynamic. This being an online course, we are not going to be affected by bad weather. However, I will often add things to the course, especially if there is some event that might be taking place, a news event that is germane to what we are talking about, and I may add it to the course. So if there are changes to the syllabus, you will be notified. Now, on the discussion board is an opportunity for you to introduce yourself. You can read about me under the Start Here section, and I'm interested in knowing your name, what you're doing, and why you're taking this class. And part of it is to help me understand. I can explain things a little more thoroughly. If I'm dealing with a bunch of journeyman carpenters, then I don't have to get into a lot of explanation of jargon. So that will help me. So let's get started with some print reading fundamentals. Some key concepts. We're going to go over to the basics. What does a drawing tell us? And are we speaking the same language? Now, I happen to be a storyteller, and I make a lot of my points with a story. And here's the first one. What do I mean by speak the same language? Remember that butcher shop my dad had that I told you about? As a kid, I would make deliveries for him on this big bike. One day he sends me out on a delivery, and I ask him how to get there, and he says, you go up West 4th Street, turn left on 6th Avenue, go here, there, etc. 45 minutes later, I come back, and I have not made the delivery. What happened? My father asked. Dad, I can't find the place. He says, I told you, just go up here to 6th Avenue. I said, Dad, that's it. I have been from one side of Manhattan to the other, and I've got 1st Avenue, Park Avenue, 5th, Broadway, 7th, 10th. There's no 6th Avenue. He looks at me and he says, what are you talking about? It's right over here by the bank. I said, Dad, that's Avenue of the Americas. He said, well, it used to be 6th Avenue. Speak the same language. Beginning with something called the alphabet of lines. These are some of the lines that we will be using, and they explain something. The object line. I'm not going to be too involved with thick or thin, but what you want to be able to do is know what they mean. When I am defining an object, I will use the object line. It is a solid line. If there is a portion that is not visible but exists, I use a hidden line, usually a dashed. Circles, I want to know where the centers are, so I use a center line. And the long, short is an indication that it is a center line. Dimension lines and extension lines. The dimension line shows the size. The extension line defines the size. So this extension line defines that the measurement is from this point to this point. The dimension line shows what that dimension is. The leader line calls out specific features. I'm trying to point to something, and I use what's called the leader line. Now, cutting plane and section line can be a little confusing because I have seen in industry this referred to as section line. For purposes of this class, this is very important. This is a section line, this is a cutting plane. The cutting plane shows you where we have taken a slice. Imagine this is a layer cake, and I have cut it in half, and I open it up to see what's inside. This shows me what I have cut apart. This shows me where I've cut it apart and the direction I am looking. That's what these little arrows are for. Sometimes I have something on a drawing that is so big and so repetitive that I can't fit it all on the drawing, or I don't need to draw all of it on the drawing. And so I use break lines to show that there's something in between here that I'm not showing, but you don't need to know. And its dimension may not be to any kind of scale. Sorry about that. Arrowheads, slashes, or dots. That terminates a dimension line. The limit of a dimension line is shown by the extension line. Again, an important consideration. So each line on a drawing has a specific function, and you can see here how they all come into play. So how do we get a set of plans? We start with the design construction process. The owner has a need, and we call that the project. He finds a designer who will create a solution. We call that the design. Now the designer has to convey that solution to a contractor so the project can be built. And he does that with construction documents, which we will call the plans. So we can do project design manually, basically a pen and paper calculation. How thick is the pavement? What's the square footage of the house? We can get computer aids to do this. Now, you're all familiar with AutoCAD, but the FAA, the Federal Aviation Administration, has software available to allow you to compute how thick pavement should be for airports. And of course, you can do similar things with AutoCAD Civil 3D that you may once upon a time have done with pen and paper calculations. Now I have a design. Now I have to convey that information to a set of drawings. So how do I do that? Well, I can do that manually, basically, again, using pen and paper. Over the years, drawings have been done with ink on linen, or ink on paper, or ink on mylar. We would letter it with a Leroy lettering set, or using a T-square and triangles. And again, today we have computer-aided methods. AutoCAD or TurboCAD, a less expensive version, and the use of plotters to actually do the drawing. This happens to be a Leroy lettering set. It is a manual way to create much better lettering than freehand. You can see here there's a little track, and I trace the letter, and there's a pen here that will then create the letter. You notice all different sizes. They get progressively larger. In some cases, numbers are on the back side, lowercase and uppercase on the other side. In this case, because the letter starts getting so much bigger, we have lowercase on one side and uppercase and numbers on the other side. And you can see how much bigger these all get. Now, I have a set of plans. Unless everyone is going to share the same set of plans, I have to make multiple copies. How do I do that? Again, in the old days it was done manually, simply recopying the drawing over and over again by hand. Think monks and abbeys. Then there was the blueprint. And this existed pretty much from the 1840s to 1940s. Then came the Diazo print from the 1940s to about the late 1980s. And then there were Xerox prints available, still are today, and computer-aided with the use of plotters. This direction here, looking here, this is the photo, and there's Manhattan across the way. Here's another view of it, and these two tracks go up under a tunnel underneath the Jersey Palisades, and this is what it looked like at the time. Then we come to a Diazo print. This came about in the early 1940s. It's a light-sensitive chemical-coated paper, similar to the blueprint, except when it was exposed to ultraviolet light, the chemical in the clear or white areas was developed in a ammonium hydroxide bath, and it washed this chemical away and converted this to a blue line. So these were referred to as blue line prints. In later years, they were able to make the chemical show up as black or black line prints, but the process was not stable in light, so these might fade over time. And the developing process needed venting and limited exposure to the people who were working on it because of the use of the chemicals. Of course, Xeroxing is basically an office copier on steroids designed to photocopy large format, 24 by 36 inch sheets. And then there's the plotter. Again, consider this the inkjet printer at home on steroids. And again, with the same process as your inkjet printer, I can print a 24 by 36 inch color drawing in about 2 minutes. So let's talk about projections. Orthographic is from the Greek meaning straight or upright, vertical, perpendicular, basically plan and elevation. It gives us eventually 6 views. This is 3 of them. There's a front view, there would be a back view, 2 side views, a top view, and a bottom view. Basically, they fold out like a box and enables us to visualize or label various points. And sometimes there might be special views that will explain surfaces that are not parallel or perpendicular to regular planes. There's the isometric view, and this is a 3-dimensional view based on the 30-degree angle, and it will show us views that they would appear to the human eye, and they're good for describing relationships of sides, whereas the orthographic view would be used for individual features. So when you're using isometric or orthographic, you want to pick the view that best describes the object. Then there's the oblique view based on the 45-degree angle, and this is similar to the isometric view, except that the front view here is in true shape and size. And being able to convert from one view to the other will help you in visualizing the part or the installation shown in the drawings. So you want to be able to go from orthographic to isometric to oblique and back again. One method to do that is known as the glass box method. Basically, your object is inside a glass box and the view from different surfaces is projected onto that glass box, and then it is unfolded, and you can see here left, right side, front side, back side, top, bottom. If you do it right, you can take your top view, front view, right side view, and you can either come up with an isometric view or go from an isometric view to an orthographic view. Let's talk symbols and abbreviations. Remember I mentioned that those would be on a map? Well, they are on construction drawings. A symbol is a graphic representation of a device or an object. Its purpose is so that when you see that symbol, you know what is being described, and there's no reason to put any wording saying this is a fire hydrant. An abbreviation is a shortcut. Again, the idea is to conserve space on a drawing. I don't have to spell something out. I don't have to use lots of words. I can use an abbreviation. Another aspect to understand is what's known as initialations or initializations. Basically the use of initials. The FAA, everyone understands this, that's the Federal Aviation Administration. But sometimes you might need some research to know what the initialization is. For example, not very many people know what SNCF is, which happens to be the French National Railway. So if you connect symbols, that makes diagrams, it'll communicate ideas. There's standardization, so everything is built the same way. Sometimes symbols will evolve due to new technologies, but the basics are going to be the same. And those symbols and the standards might be developed by trade associations like the National Electrical Manufacturers Association, or NEMA, or technical societies like the Institute for Electrical and Electronic Engineers, the IEEE. Government agencies like OSHA. Standards organizations like American National Standards Institute, ANSI, or the American Society for Testing and Materials, ASTM. And sometimes by private organizations, by National Fire Protection Association or Underwriters Laboratory, UL. So sometimes those symbols and abbreviations are non-standard. They might be project or industry specific. They may have multiple meanings. So always look to the legends and the notes for the particular project. And use your common sense. For example, here's a list of abbreviations. You can see they go all the way up to Y for yellow. But let's look at some a little closer. Here we have D, which may stand for diameter. But also we have D standing for down, or D standing for dryer. Over here we have an R for range, R for red, R for resistance, R for resistor or reverse, R for right, R for riser, and here R for radius. A word about north arrows. North arrows don't always point up. Here's a north arrow that is actually pointing down. There also may be more than one north arrow. And here's an example that this is north, but someone has designated this direction as planned north. And one of the reasons for doing that is so if I have a building that sits like this, I can refer to this as the north side of the building rather than the northwest side of the building. So again, always look for the north arrow and a plan side. Title blocks. Title block is probably the first. It's going to provide basic information for the complete set of plans. It's the first place you want to look. So here's an example of a title block from the text, the project name, project location, the name of the sheet of this particular drawing, when the plan was completed, who drafted it, is there a scale? You may find the seal from a registered architect, sheet number of 18. So again, if you were handed this sheet only, rule number 1 would apply. Who the architect is, who designed it. Here's another example of one that my company had done years ago. You can see here we have the owner and the project location, the project name, the date of the plan, who drafted it or designed it, the name of the sheet so you know what it is you're looking for, the firm that designed it, and this is sheet number 6 out of a total of 43 sheets. Notice here that the scale is not shown in the title block. So now let's talk about scales. Scale is to properly represent size because most prints are too small to show the full size. This, by the way, happens to be an undoctored photograph. Those wheels are about as tall as I am, and I am 5'9". But it gives us an opportunity to estimate the size by making use of it. So you could ask yourself, how many Ubaldes tall is this locomotive? And so it's 1, 2, about 2.5, so about 15 feet. Now, it is a mathematical relationship. 1 inch equals 100 feet. 1/4 inch equals 1 foot, or 1/25 scale. But it is also the instrument that we use to measure the dimensions. And when we use those instruments, it is designed with the mathematical relationship in mind. There is no need to convert. There are two types of scales that you will encounter. One is the engineer's scale, and it is usually involves round numbers, 20 feet, 100 foot, or the architect's scale. And these scales are 3/8 of an inch equals 1 foot. That matter. It's usually architect scales drawn, most working drawings in a set of prints, especially in buildings. I share with you figure 112. Notice the triangular cross section. That allows you to get 1, 2, 3, 4, 5, 6 different sides to the triangle. Here's a close-up of it. You read the whole numbers first, then the inches. This will give you a division of the inch. This is a 1/2 inch. This is a 1/2 inch. This is a 1/2 inch from here to here. Here are some of the different sizes that are used. But the engineer's scale will be used to draw plot plans and construction projects of that nature. Here are some of the examples of engineer's scale. And the reason for the different civil or architectural scales is that the various disciplines require different types of sizes. Civils tend toward large-scale projects, so their measurements are in feet and decimals of feet. Architectural mechanical projects tend toward fractions of an inch, such as 5/8 inch drywall, and so their scales and instruments reflect that. You need to decide what scale is going to be appropriate. A civil scale for large works is, let's say, 1 inch equals 300 feet. But if you take a situation like this, which is the Springfield, Ohio airport with a 9,000-foot runway with 1,000-foot overruns, fitting it on a... So at that scale, a 9,000-foot runway would be 30 inches long, but the width of the runway might only be a 1/2 inch wide. And so a lot of items would be too small to show in detail. Let's take this intersection here, which simply looks like an intersection of pavement. But when I use a different scale and make it larger, we can see much more information is available. Meanwhile, if I'm using an architectural scale of 1/4 inch equals 1 foot, if I draw a 12-inch object, it will be 48 inches long and much too large to fit on a page. Keep in mind that not all drawings on a single print will be drawn to the same scale. Here's an example from the multifamily dwelling in the text. If you look at this area here, you see it's to a scale of 1/8 of an inch equals 1 foot. In this corner here, it's to a scale of 3/4 inches equals 1 foot, and these rooftop units here show a scale of 1 1/2 inches equals 1 foot. Again, always read the plan for those scales. Now, how do we use those triangular instruments, the scales, to measure things? Well, I want to give you an example, what I call the Suzy Q. This is the New York, Susquehanna, and Western Railroad. And here is a real boxcar from the Suzy Q, slightly worse for wear. Here are two models of the exact same boxcar, one in HO scale and the other, as you can see, much smaller in N scale. Now, I am using here a scale that is designed to measure things in HO. And when I measure from one end of the boxcar to the other, I see that the boxcar is 40 1/2 or 40 feet 6 inches long. When I measure the N scale, again, same device, but now this says I am measuring N gauge material. It tells me that, once again, I am 40 1/2. And lo and behold, the interior length of the boxcar is 40 feet 6 inches. So I do not have to do any calculations. I can measure it exactly off of the scale. So here are some examples of how it would work. This is 1 inch, and so that is 100 feet. So if I take the A dimension, you can see that it is 100, 200, 300, 350, 60, 70, 375 feet. This dimension, B, is 225, and the C dimension is 175. If I go down to here, this is an architectural scale. Notice 1/4 inch equals 1 foot. This is 1/4 of an inch from 0 to 1/4, and so that would indicate 1 foot. If a drawing was made from here to here, that would tell me it'd be 1 foot. Here's the other 1 foot. So when I'm reading this scale, I want to ignore these numbers here and use these numbers here. So if I look at D, I measure the whole numbers first. So this is 15. And then I measure the divisions, which would be inches. In this case, this would be 6 inches. This would be 12. So this would be 9 and 3. Gives me 15 feet 9 inches. E be 8 foot and 6, and F would be 5 foot and 2. Another way to look at it, here's a 10 scale. Here is a carpenter's rule. That is 1 inch. And lo and behold, it measures to the 10-foot mark. Here's a 20 scale. Here's my same 1 inch, but now I read 2 or 20. And a 30 scale. again, 1 inch, and I read 30. Here's some more examples. Here's a 40 scale is 1 inch equals 10 feet. My 40-foot taxiway pavement area, 1 inch equals 10 feet, 40. Here's another example. 1 inch equals 2 feet. So here's my 5-foot typical from here to here. From these 2 points is 0.5 or half a foot. So what would this distance be? If this is 5 and this is a half, this should be 4.5 feet. So when I measure it using a 20 scale, in this case I don't have to worry about the 0, I measure 1, 2, 3, 4.5 feet. No calculating is necessary. And again, here's my half foot already measured. Here's another example. 1 inch equals 1 foot, 8 foot 6 inches. Here's my 8 foot. I measure the whole numbers first. Then I measure my inches, 8 foot 6. If you look at this 5.5 up here, okay, 1/2 inch equals 1 foot. Here's my 1/2 scale. I measure this way, 0, 1, 2, 3, 4, 5, whole numbers first. And what inch do I have? I have a half, so 5.5 inches. Same thing, 2 3/4 between there, the whole number, and the decimal. So rule number 18 of print reading is when you're using a scale, if you have to multiply to get the answer, you've already gotten it wrong. So let's talk about some dimensions. Dimensions show size, they show relationship, and they show location. But do not scale off drawings, because the line width may affect the dimension. Where would you start the measurement? At the beginning of the line, the beginning of the width of the line, the middle of the width, the end of the width. So always rely upon written dimensions. Now, the caveat to that, the exception is that if you're just looking for very rough estimates, it's okay to scale off the drawings. So here's an example. This is a track plan of the Cuyahoga Valley Scenic Railroad from around 1919. And let's zoom in on a part of it. We see here a milepost 50. And this little tick mark indicates milepost 51. So you can see how thick this line is. Where do I measure the length of the curve? Do I measure it from here, or this side, or the middle? So you can see why it'd be difficult. If is another way to look at it, again, another example, read the whole number first, then read here 8 feet 6 inches. If this could be 8.5 inches rather than 8 foot 6, depends on what the scale is. If you do not have a scale, then you can use a regular ruler. Then you have to do some math. But if you're using an architect's or an engineer's scale, you will not have to do any kind of math. Where there isn't room to write a dimension, we'll use a leader. 5.5 inches, telling you that this location here, because there's no way I could fit 5.5 inches in there. Or I may have extension lines that put all my dimensions in a row and outside the clutter of the drawing. I can break my dimension line with my dimensions, or I can put my dimensions on top of the dimension line. Either one is acceptable.